Hi folks, welcome to your first day of our final review. So this is meant to serve as the key takeaways of what you should walk away from knowing from trimester 3. So today we're going to start with chapter 4, moving to chapter 5 and 6 in the following days. If we were to have like a final, this is like the type of content that could be on the final, but we're not, don't worry, we're not having a final in my class. Alright, so chapter 4 started off with talking about polynomials, and we actually finished the end of trimester A talking about polynomials. So this was a little bit of a review chapter. But remember that a polynomial is a function that has multiple terms. And we remember that because poly means multiple and nomial means term. So a polynomial, by definition, is something with multiple terms. There were characteristics that we learned, and the three most prominent ones were standard form, degree, and leading coefficient. So if we have something like 6x minus 5x to the fourth plus 3, right? Standard form tells us, hey, we have this negative 5x to the fourth term, that one should be up front, all right? And then everything, it should be up front because it has the biggest power of x. And then everything with smaller powers of x should follow sequentially, right? So like if we have negative 5x to the fourth as our first term, we would have an x cubed as our second term if we had one. And then an x squared, and then an x, so on and so forth. All right, so that's what standard form means is, hey, make sure you have it put in the right order. Degree is always the biggest power of x, or the biggest exponent. Now, sometimes if you get into like higher levels of math, you'll have to like add numbers and stuff, but with ours, we're only ever working with x as our variable, and so the degree is always just whatever the highest power is on your variables. All right, and your leading coefficient is always the number that's in front of the biggest power of x. All right, so in our case, standard form would be negative 5x to the fourth plus 6x plus 3. Our degree would be 4 because it's our highest power of x, and our leading coefficient would be negative 5. All right, after we reviewed what polynomials were, we went into what to do with them. So one of the things you can do with polynomials is you can add and subtract them. Remember that anytime you're adding and subtracting, all you got to do is combine like terms. All right, and it's really important to remember that you have to distribute the negative when you're subtracting. So if we had something like 3x cubed minus 4x squared plus 2, right, minus 5x cubed plus 2x, all right? We have to remember that our first step is always to distribute this negative inside. But remember, it doesn't just go to that first term, it goes to all of the terms. All right, so our next step would be our 3x cubed minus 4x squared plus 2 minus 5x cubed and then minus 2x. All right, because I had to distribute in that negative. If this was instead a negative 2x, then that would be positive 2 after distributing in the negative, all right? So in this case, both of our coefficients were positive, which is why after distributing in the negative, both of our coefficients are negative. All right, at this point, all you have to do is combine like terms. So even though this was a new concept, you had already done many examples like this in earlier math classes. It's just that it wasn't necessarily phrased exactly like this. All right? So you just combine your like terms with your 3x cubed and your negative 5x cubed, so on and so forth. All right? And then we had our multiplying, and we also had some dividing, but dividing was primarily in trimester A. When we were multiplying, though, this came up later on when we were multiplying functions, right? And remember that anytime you're multiplying, you always multiply the coefficients, all right? And then you add the exponents. So if you have like 3x squared times 5x, right? Remember that you're always multiplying the coefficients, so 3 times 5 gets us 15, right? And then you're adding the exponents. So x squared times x gets you an x to the 2 plus 1, which is an x cubed, all right? When it asks you to solve polynomials, that just means that you have to set your function or your polynomial, you just set it equal to 0. You're going to factor it if you need to, and then solve for x. So solving polynomials is just one extra step. All right? So if we had 15x cubed equals 0, right? All we have to do to solve this is divide by 15 and then square root both sides. All right? So just because it says, oh, you have to solve for a polynomial, that doesn't mean that you don't know how to do it. All right, you all know how to solve polynomials because you just set it equal to 0 and factor it, and then you just solve for x. All of you have been solving for x since middle school, so you're doing okay. All right. Then we came into the part of the chapter which was the meatier portion, right? The portion that we needed the most amount of practice with. And that was the factoring portion. So factoring, we split it up into a few different days and into a few different ways of talking about factoring and learning how to factor. But a lot of the times, we had to factor out the greatest common factor. So we had to factor a monomial out of a big group. So we had to, maybe we had 3x to the 4th plus 12x squared minus 9x. All right. In situations like that, when we're asked to factor, it's easiest to start by factoring out the greatest common factor. And the greatest common factor is almost always the leading coefficient and the smallest power of x. All right. So we factored out a 3x, and when we do that, that means we take each term and divide it by 3x. All right? So that meant we were left with an x cubed, 4x, and a minus 3 on the inside. But the total, the final answer would be 3x times that x cubed plus 4x minus 3. All right, so whenever you're factoring out a greatest common factor, you just, as long as it's a monomial, you just divide each of the terms by that monomial. Sometimes, though, we're not factoring simple things. We have to factor things like binomials, all right? Remember, anytime you're factoring out binomials, you learned this back in Algebra 1, all right? But when you're factoring out a binomial, you're always going to start with a factor tree of C. Then, you're going to add the factors to BB. All right? So those are your key steps when you're factoring out a binomial. Now, sometimes your binomial has a number in the very front that's not 1. So if you have a number that's not 1, then you're going to create a factor tree for A and C. And then you're going to multiply the factors of A with the factors of C to see which ones add to BB. All right? Now, the last type of factoring was probably one of the more difficult types just because it was very new to most of you, and that's our factor by grouping. All right? So when you're factoring by grouping, you always group the first 2 and the last 2 terms. So this happens when you have 4 terms. So if we have 5x to the 4th minus 20x cubed, all right, minus 3x squared plus, let's say, 12x. All right, so I just made that up on the spot, which is why it took me a little bit, but that's okay. So anytime we're factoring by grouping, we're always going to group the first 2 and the last 2. Remember, though, if you are grouping something with a negative sign on the outside, you have to change the sign on the inside. All right? So this plus sign gets changed to a minus sign, which makes sense because think, if you were to distribute in this negative, you get negative 3x squared, which is what you have, all right? And then you get a positive 12x, which is what you started with, all right? All right. So now, after you group the first two and the last two, then you have to factor out your greatest common factor, which remember is almost always leading coefficient, smallest power of x. Leading coefficient, smallest power of x. So we're going to factor out a 5x cubed from our left term and a 3x from our right. All right, so each of these two on the left get divided by a 5x cubed, and each of the two on the right get divided by a 3x. Oops, not an x squared. All right, 5x to the fourth divided by 5x cubed, left with just an x, minus 4. We have 3x squared divided by 3x, we're left with just an x, and then negative 12x divided by 3x, we get minus 4. This is great because look, we have two groups that are the same. All right, so our first group we have is x minus 4, and then our second group is what makes up our outside pieces, right? That 5x cubed and that negative 3x. And in this case, this one can simplify down more, so you could go in and factor in here. You could factor out your greatest common factor, which 3 and 5 are both prime numbers, so you won't be able to pull out any numbers, but you should be able to pull out some x's. Alright, we are now at the end of the video, which is great. So that final question I'm going to have you answer for today is, if you could go anywhere in the world, right? I know we've all been cooped up, we've all been quarantined, and we just want to get out. If you could go absolutely anywhere you wanted to, where would you go and why? I'm just curious, and also I'm also getting a little stir crazy, and I'm excited to be able to join the world again. All right, that's all I got for you today. Thanks for watching.